Hello friends, I'm Professor Swanan Dongre and in this video we are going to learn how to draw the circuit diagram of the configurations of BJT, and after that we'll see what is the meaning of input characteristics and output characteristics in each configuration. So first, to draw the circuit, let us consider any configuration, that is common base or common emitter or common collector. So friends, you have to remember few tricks to draw these circuits. First trick, we identify the common terminal. For an example, in common base configuration, base is the common terminal. So if you have identified this common terminal, in the circuit diagram, what is general practice? The common terminal we show at downward side. So you have to show in common base configuration, you have to show that base terminal to the downward side. So that is at one side you will have collector, at another side you may have the emitter. So base, which is the common terminal, you have to show on downward side. Then in the circuit diagram on paper or on a board, we show the input at the left hand side and the output to the right hand side. So that is why whichever the input terminal in that given configuration, you have to show that input terminal to the left side, output terminal to the right side. Let us consider common base configuration and NPN transistor. So we have to draw the circuit of common base configuration using NPN transistor. So here in common base using NPN, as the name indicates, it is common base configuration. In common base configuration, base is the common terminal. So that is why you have to rotate the symbol, you have to flip the symbol of the transistor so that the base will come at downward side. So here I am showing the symbol, see here. So this is the base terminal at downward side, and out of remaining two terminals, one will be emitter, second will be the collector. We'll see the emitter and about emitter and collector later. So this is the first step. After that, which is the input terminal in common base? So how to remember this? Do you remember that area trick? Out of remaining two terminals, the terminal with more area you have to consider at output side. So common base, out of emitter and collector is having more area, so take it on right hand side, that is output side, while emitter on left hand side, that is input side. So that is why here the terminal with arrow, that is emitter terminal, I shown at the left side, that is input side, and collector, that which is the output terminal, at the right side. As it is NPN transistor, the arrow direction, it is outward, and this arrow direction indicates the direction of conventional emitter current. So this is the first step. We have drawn the symbol, we have shown the common terminal, we have shown the input terminal, we have shown the output terminal. Then what you have to do? Show one terminal, one resistor in series with the output terminal, one resistor in series with the input terminal. As it is connected in series with this input terminal, call this resistor as R. Input terminal is E, so RE, and this resistor as RC. So this is second step. Then friends, we have to bias this transistor in appropriate region of operation. So either saturation region, cutoff region, or active region, so that transistor can be used as a closed switch, open switch, or as an amplifier. So biasing is essential. So what we'll do, we'll connect one supply, DC supply, for biasing in between input and common terminal, and second DC supply in between output and common terminal. And the main function of transistor, it is used as an amplifier. So in that diagram, you have to adjust the polarity of this DC supply such that emitter base junction is forward bias and collector base junction is reverse bias. So here, what I have to do, I have to show a supply between input terminal and common terminal. Here I have to connect that DC supply. I'll show the polarity later. Then this supply between output terminal and common terminal to forward bias the emitter base junction and reverse bias the collector base junction. Now what do you have to do? First we have to forward bias the emitter base junction. This is NPN transistor. Emitter is N type, base is P type, collector is N type. And what we have to do? We have to forward bias this emitter base junction. Forward bias means anode means P type material should be at higher potential, cathode, that is N type material, should be at lower potential. So that is why I'll show such polarity here. N side at lower, P side at higher, that is negative positive, and name of this supply as it is connected to input emitter terminal, it is VEE, right? Then what do you have to do? We have to reverse bias the collector base junction. Collector is N-type material, base is P-type material. Reverse biasing means P-type should be at lower potential. So that is why lower potential at base and higher potential at the collector, so that this collector base junction will be reverse bias, and as this supply is connected to collector, so it is VCC. So this is the simple circuit diagram. First we have identified the input terminal, common terminal, output terminal, input terminal downward side, the common terminal downward side, input terminal left side, outer terminal right side. Show one resistor in series with the input, one resistor in series with the output, and connect a DC supply between input and common, and second supply between output and common, so that base emitter junction is forward bias, collector base junction is reverse bias. So that's the simple tree. Now friends, let us draw the circuit of common emitter configuration and consider the PNP transistor for an example, right? So we have to draw the circuit of common emitter configuration, and the type of transistor is PNP. So here, as the name indicates, it is common emitter configuration, and in common emitter configuration, emitter is common terminal. Out of remaining two terminals, that is base and collector, collector is having more area, so that is why we have to take it at output side, means the right hand side, while base at input side, that is left hand side. So I'll flip the symbol of this transistor, PNP transistor, so that the emitter will be at downward side, base will be at left side, and the collector will be at right side. So here base is on left side, base is on left side. The emitter is common, means downward, means this will be the emitter, and obviously this will be the collector. See here. So here the circuit, we are having the common terminal, which is base terminal, then the common terminal here, it is the emitter terminal, which is at downward side. Base is the input terminal, which is on left hand side, and obviously the third terminal is collector, and the type of transistor is PNP. So that is why this emitter is having arrow which is inward, and it gives the direction of conventional emitter current. Now what is next step? In next step, we have to show one resistor in series with the input terminal, and the second resistor in series with the output terminal. So here I'll show one resistor in series with the output terminal RC, then one resistor in series with the input terminal RB. Now what I have to do? I have to connect a supply between input and common terminal, and second supply between output and common terminal, so that this base emitter junction is forward bias and collector base junction is reverse bias. Now here the type of transistor is PNP. So emitter P type, base N type, collector is P type. So what do you have to do here? Here the base emitter junction should be forward bias. Base emitter junction should be forward bias, because the basic application, main application of transistor, it is an amplifier, and for amplifier transistor should operate in active region, and in active region the base emitter junction should be forward bias, EBFB, while the collector base junction should be reverse bias. So forward bias means what? P side should be at higher potential, N side should be at lower potential, so that is why higher lower. So this is nothing but the input supply which is connected between input and common terminal, and name of this supply as it is connected to base, it is VBB, right? Now second, we have to reverse bias the collector base junction, but if we consider here there is no direct supply, DC supply connected between collector and base. The supply is connected between collector and emitter. So what we have to do? We have to connect the supply here in between collector and emitter, so that indirectly the collector base junction will be reverse bias. So for that you have to remember one trick. We have seen that if you consider any DC supply, battery, right? So in that DC supply, if it is say 10 volt supply, it is always absolute, it is not absolute potential, it is potential difference. Meaning is that I can't predict the potential at negative terminal alone or positive terminal alone, but I can tell the potential difference. So if negative terminal of this supply is treated at X potential, the positive will be at X plus 10, that is above negative potential by 10 volt. So same trick we can use here. Let us assume that this VBB, it is of say 5 volt. VBB is of 5 volt. Now in this circuit, I'll treat this emitter terminal as a reference terminal, and I'll assume that the potential at this reference terminal is 0. So that is why, as per my assumption, emitter is at 0 potential. Same potential will have at the positive terminal of this 5 volt supply. So positive terminal of this 5 volt supply is at 0. So negative will be below that by 5 volt. Hence at negative the potential will be minus 5 volt. Neglect the drop across this resistor RB. Hence the base is at minus 5 volt and emitter is at 0 volt. Now what do you have to do? We have to reverse bias the collector base junction. Reverse bias means P side should be at lower potential, N side should be at higher potential. At N side we are having minus 5 volt. So at P side we should have the potential which is less than minus 5 volt, so that it will be the collector base junction will be reverse bias. So here less than minus 5 volt means, say for an example, minus 10 volt, right? So at collector I will require minus 10 volt. Neglect the drop across resistor. So here I want minus 10 volt and here I am having 0 volt. Now you have got the idea of polarities. Minus plus minus plus. That is, and the name of this supply is as it is connected to collector, it is VCC. So this is how we can draw the circuit diagram of any configuration: common base, common emitter, common collector, either it is NPN or PNP transistor. So we can draw all these 6 circuit diagrams. Thank you.